All right, we'll go ahead and get started here. So I mentioned this right at the beginning of the call, but Andre had a conflict, so he's not going to be here today. It'll be just me. And there's really two goals for this workshop. One is I wanted to provide just a sort of a high level walkthrough through the contract itself. We're not going to be able to cover everything because that would take hours, but just covering the main high level functions and some of the parameters to pass in, some of the checks that those functions will run. And the goal here is really to give you guys a high level familiarity with the contract so that you can better understand what's actually happening and when, and be better able to identify bugs and errors and everything when they do occur. So I'm going to take you through a new page on the docs that I just published yesterday, and this is another one that'll be just continuously added to and updated over time based on feedback that I get from everybody. So that's the first thing. And the second thing that I want to do is go through some of the stacks.js methods for actually conducting these stacking operations, because I know there's quite a few that don't necessarily want to use a UI. And so we'll go through how you can use stacks.js to do some of these stacking operations. And again, the goal for today is not necessarily to give everybody a super in-depth understanding of every piece of this, but it's to give you just a high-level overview of the process and the tool so that you have a good starting point. And then from there, whenever you run into questions, errors, whatever, you can reach out to me, and then I'll get those things added to the docs and get those questions answered and everything. But this way, everybody has a good starting point for how these stacking transactions work. And then if you want to use the JS library instead of the Lockstacks UI, then you'll have that option too, and you'll know where to start to go looking for that. So hold on one second. Andre is the host, but he's not here and he has disabled screen sharing. So one second, I'm going to ping him. Be right back. Okay, while I wait for Andre and hopefully get the screen sharing issue resolved, I'm just gonna drop some links into the chat so that way you guys can all um, go and check out the pages for yourself. Oh, looks like Andre's here. Okay, hold on one second. Still gonna
Yeah,
grab
should
this.
be fixed, Kenny.
Cool, awesome, thank you. Yeah, there we go. Cool. All right, so I just dropped this link into the chat, but this is there's a section on the docs in the clarity section called example contracts, and there's a stacking page here, and this just serves as sort of a walkthrough of the stacking contract. This is not 100% complete yet. There's still some functions and errors that I want to get more documented, but this is a good high level overview, and we'll cover most of the common things that everybody's going to be needing. So the first thing that I want to do is just quickly walk through the solo stacking function, and then we'll walk through the delegated stacking function here too. But so whenever you use the lockstacks UI or the stacks.js library or whatever method you do, if you're doing solo stacking, you're going to call this stack stacks function in the POX contract. And that's going to take several parameters. It's going to take the amount in UStacks or microstacks. And so one stacks is equal to 1,000,000 microstacks. And so that's how this is denoted here. This is basically the Bitcoin address for the rewards, and this is the format that it takes. It's a tuple that corresponds to the version, and there are several versions that you can pass in, and I have those outlined back on the how to stack page, which ones you can put in there. I'd actually have that outlined here now I think about it. Yeah, so if you look right here, These are all of the different versions that you can pass in depending on what type of Bitcoin address you have. And then this second part here are the hash bytes for the rest of the address. After you have the version number, then you'll have the actual address itself there. And there are libraries available for encoding this stuff in the way that needs to be formatted to pass through here. And then the start burn height. So what this is going to be is this is going to be a Bitcoin block height that corresponds to the reward cycle that you want to start stacking in. Usually if you're calling this as a solo stacker, you're just going to do something. It needs to be something that results in the next reward cycle, basically, because what you're going to see right here is a check here to make sure that the first reward cycle is equal to the specified reward cycle. Lock period is how long, how many cycles you want to lock up your stacks for. And then the signer signature we've talked about before, but this is the signer signature that you generate. And we'll go over how to do that today with Stacks.js. But this is the signer signature that you would generate, for example, in the Lockstacks UI, just to prove that you actually own the public key of the signer that you're passing in right here. This is the max amount that can be stacked. And this is just the auth ID is just a unique string to prevent reuse of this stacking transaction. So once we pass those parameters, we go through several checks just to make sure everything is valid. The first thing is that we need to make sure that the stacker's first reward cycle that they've passed in here is the next reward cycle. That's enforced here at the contract level. So if you're solo stacking for the next reward cycle. Making sure the contract caller is allowed, making sure that they're not already be stacking, making sure that they're not delegating. So if you want to solo stack, you can't also be delegating to somebody else. That you actually have the amount that you need, making sure that the signer key is valid. And then this can stack stacks is a check. There's a read-only function corresponding to this so that you can call it externally if you need to. But this is a function that's reused in a lot of these stacking transactions that'll go through a few different checks just to make sure that this stacking transaction is valid and that there's nothing in place that would prevent this stacking transaction from going through. And then what we actually do here is we'll set the stacking state to match the information that we just passed in, assuming all of that is valid. And then this returns with a success message and all of this information so that the node can actually carry out the lock, so that the stacks node can read this transaction, see that these stacks are locked, and actually enforce that lock. And so that general process with those parameters and all those checks is going to be pretty common throughout these different stacking transactions. But if you do submit a stacking transaction and it fails, if you go to the transaction page in the Explorer, it will give you an error ID. And then the best way to figure out what's going on is just to go to the actual contract itself, find which error message matches the error ID that you got, and basically search in the contract and trace exactly where the error happened. And we'll go over a couple of the most common ones that I've seen so far, but that's the general process. And there's a lot of different errors that can happen because there's a lot of different checks that happen. So depending on which stage of this fails, that'll give you some insight into what parameter you need to change or what information you passed that was different than what it needed to be. This is what we already all talked about. And then I just have the same walkthrough here for all of the delegation functions. So delegate stacks, remember, is called by the person delegating to the pool operator. Again, some similar stuff happens here. A few different parameters like the amount, who they're delegating to, how long they want to provide this permission to delegate until burn height, again, corresponds to a Bitcoin block height. And then this is an optional reward Bitcoin address for the rewards that the delegator can pass. If they pass this, then the pool operator is required to designate this as the Bitcoin reward address where the delegator will receive the rewards. If they don't pass this, then it's at the discretion of the pool operator to decide where those Bitcoin rewards get distributed. And then we go through some similar checks here, making sure they're actually allowed to stack. Check to make sure that the Bitcoin address they provided is legitimate. Make sure they're not already delegating. And then we'll set the delegation state, which is very similar to the other one where we're just adding in the information here to update the contract state. Once this transaction has confirmed, then it's up to the pool operator to call this delegate stack stacks function, which will then read this information and compare it to the information that the pool operator passes right here to this function. So what this function is going to do is it's going to take everything that you pass as the pool operator, it's going to compare it to what the delegator passed in their function and make sure that it all matches up. And if it does, then it's considered legitimate. And at this point, after this transaction is confirmed, it'll go through a lot of those same checks. And then down here, this will actually update the stacking state. But the other thing that it'll do is it'll update the partial stack state. So the stacking state is updated at this point, but because this partial stacked state exists as well, these stacks are only considered partially locked and not actually locked. So now the last step is for the pool operator to run the stack aggregation commit function. And this function is what will take all of those delegations, wrap them all up, and lock them all simultaneously. If the pool operator does not call this function, then these stacks don't ever actually get locked once the reward cycle starts. This function is necessary to actually do that. And what this will do is it will take all of these delegations and it will collect them all up. And basically, since the stacking state has already been updated here, what this aggregation commit function actually does is it removes the state from the partial stacked. So now these stacks are considered fully stacked after this transaction confirms. And again, this will go through a lot of the same checks here. It's got a lot of the same parameters as the other one. It'll go through a lot of the same checks to make sure that we actually have permission to do this, that all the information matches up, and it'll carry out that action. So yeah, you can, I posted this link in the chat. You can go through this and walk through and kind of get a better understanding of the different parameters, the different functions and checks that happen. One exercise that I would recommend you do if you're interested in deeply understanding the contract is just to go through and trace all of these different checks so that you can see exactly what is being enforced at the contract level for stacking when you go through these. We're not going to do that on here just because that would take forever and probably be extremely boring, but this is the high level overview so that you can kind of go in and dig into which points are relevant for you and what you're curious about specifically. And then the last thing I wanted to go over real quick before we jump into some of the JavaScript stuff is that these were the two errors that I've seen the most often. And I specifically wanted to go over error 35 because it's a little bit confusing, just the name of the error. The name of the error makes it sound like the public key that you passed into your signer signature was not correct, which is one possible way that you can get this error. But the other way that you can get the error, the one that I've seen more often than not, is that there's some information between what you passed in to your signature generation versus what you passed into your, for example, your stack aggregation commit function. So for example, if that information needs to match for every single transaction. So if there's even one parameter that's off, then your signature is technically considered invalid, and then you'll get this error 35. So if you see this error, make sure that you go in and actually check to make sure that all of your fields match, because most of the time that's why people get this error. Second one that I've seen a couple times is error number 4. And this happens when the contract is looking up the partially stacked stacks, which is where at this point that means that you've called the delegate stack stacks function. It looks it up using this key, the Bitcoin reward address, the stacks address, and then the reward cycle. And so if any of those parameters are wrong when you're calling this stack aggregation commit function, then you're going to get this error number 4. And it just means you need to fix one of these because it can't actually find it in the state. So I'm going to pull up the chat real quick and go through these before we jump into the JS section. Okay, looks like we got a couple of these answered. Ready? So Hank, I'll have you jump in here to clarify my answer and make sure I'm correct. But for these last two, this is, as far as I know, and again, I'll have Hank correct me if I'm wrong, this is basically up to the discretion of the pool operator and how they want to do things. I think most pool operators will implement their pool via a smart contract so that this portion will happen automatically. But yeah, I'll have Hank jump in if that's incorrect or if there's more context there.
Yeah, and also because many pools, they've got lots of users that might not be delegating very much stacks. And uh, proof of transfer basically specifies a minimum kind of like per Bitcoin address that's able to kind of receive a reward slot. And so generally there is a level of trust where the Bitcoin is going to the pool operator's Bitcoin address, and then the pool operator has some mechanism for distributing those rewards, sometimes through a smart contract, sometimes on BTC directly. Yeah.
So for this first question, where they have three delegators that have called that have delegated stacks to their pool, two of them specified an address, a Bitcoin address, and one didn't. What do they pass into that stack aggregation commit function in that case? And
Yeah.
where does that enforcement come in actually of the like Bitcoin address that the delegator passed in?
Um, in that case, you reference the like partially stacked amount when you're going through the contract. And the kind of lookup key for that is tied to the Bitcoin address that's specified. So you could be like having kind of three sets in that scenario. One where it's, or two where it's the first two separate users' Bitcoin address, and then one where you specify it yourself. And then you'll have to call stack aggregation commit for each of those sets as well.
Okay. And that type of functionality is what a lot of pools will write into their pool contracts to manage all that automatically. Is that correct? Or is this all manual stuff that needs to happen no matter the pool model?
Um, it depends, and also some pools, they have their own web apps that are kind of like specifying the arguments that users make. But yeah, a lot of pools do have kind of their own kind of infrastructure, and one common pattern is to have a sort of wrapper contract that allows you to batch these operations. So instead of making 100 delegate stacks transactions in one stack aggregation commit, they've got some sort of batching functions, so it's only one or two individual transactions.
Okay, cool. Yeah, so even for this, a couple more questions came in. For this first one, can we operate a native stacking pool and a custom stacking pool? If so, how to handle multiple commits? So even if you have a custom stacking pool, you'll still need to interface with this POX4 contract. You'll just basically create abstraction layers and utility functions depending on how you want to handle those commits and those transactions. So even pool operators running their own pool through their smart contract, they have their own helper functions and their own wrapper functions, but they're still calling POX4 to actually stack. No matter what, you'll have to call this main contract to stack. It's just up to you if you want to implement another contract on top of it as an abstraction layer to handle the pool however you want. And then second one. Yeah, Hank, this last one, I think I've seen asked before, and I think you
Mhm.
provided an answer to it if you want to jump in for that one.
Yeah, that's related to the comment I made before.
Okay.
I definitely understand that it's a lot of interaction, kind of at like if you're interfacing with the POX contract directly. Um, it's really because there's different use cases. Some pools might have different rules about who they're going to allow to delegate to them, and so they might want to behave one way. Others that are just kind of anyone can join. Maybe you just have some, script that runs every cycle to kind of just batch it all together and, not have to do any interaction. And so it is up to, kind of the use case if you're running a pool. And I think definitely just reach out and we can, share information and kind of share examples of how other pools have done it.
Awesome. Cool.
And and then that last question about best way to kind of test these things out. Yeah, I understand that testnet blocks can be pretty slow. I will say after testnet is upgraded to Nakamoto, that really shouldn't be a concern. But then separately, there are ways to run like what we call a devnet or a reg test environment, where it's everything's super fast blocks. You just kind of run it locally. It's great for app development. And so we can also share more information about that.
Yeah, I'll post a link to Clarinet in here real quick. But if you use Hero has a tool called Clarinet that'll allow you to spin up your own local DevNet pretty quickly and easily. And within their DevNet that's built into Clarinet, it will automatically deploy the POX contract as a boot contract. And so you'll have access to it within that DevNet. And then you can set up your stacking flows however you want in something that's localized and yeah, extremely fast, like a couple seconds per block or something like that. I believe, don't quote me on this because I'm not 100% sure, but I think you can change the reward cycle time within the DevNet config file. You'll need to look at the hero docs to verify that, but I'm pretty sure that's one of the options. But
Yep.
okay.
Yeah. And then you'll just, every wallet and every library allows you to specify kind of like the node URL. And so you can just point to that and then change that URL for your mainnet infrastructure.
Cool. Okay, so let's jump into the Stacks.js stuff real quick. Here. Actually, looks like we have one more question. We can go over that real quick before we switch gears. For that last one, Hank, don't delegators pass in how long they want their stacks to be delegated for, and then they can extend it, or do they need to redelegate every cycle?
Um, Essentially, yes. I need to look into the exact arguments that need to be passed there. But yeah, there are ways to for a user to just stay delegated. And then you as a pool operator will mainly just need to do the aggregation step for reward cycles. And you can actually do that for, a future reward cycle, like, 2 or 3 from now. If you already have some partially stacked stacks, then you can call that commit function. There's also a stack aggregation commit increase. So yeah, you can definitely optimize that a bit.
So they're not limited to only committing for one cycle in that stack aggregation commit
And stack aggregation committed is one
in that.
cycle at a time, but you can call that function for 3 cycles from now or 4 cycles from now. And so and then similarly you can batch things like that.
Okay. And that's the difference between the stack aggregation commit and the stack stacks function. Stack stacks function has to be called for the next reward cycle, but stack aggregation commit you can call for future reward cycles.
Yep,
So
exactly.
you do
Yep.
have to call it for every reward cycle, but you can do that ahead of time. You don't have to do that in real time as the cycles come up.
Correct. And the only caveat being that if someone delegates more to you or new users delegate more to you for that, upcoming reward cycle, you'll have to call this stack aggregation commit increase function to sort of still finalize that exact cycle.
Okay, cool. All right, let's jump into the Stacks.js stuff. First thing is Hero has this guide on their docs for work integrating stacking into Stacks.js. But there's a couple of things here that I want to go over because there's a couple pieces of information that are a little bit scattered. So this walks you through how to basically run a stack stacks function using Stacks.js. And it'll walk you through installing the npm packages you need, generating an account, which you may or may not need to do depending on your setup. In all likelihood, you'll already have an account and a private key that you want to use. And then there's a few functions displayed here for displaying stacking info. There's a lot built into the Stacks.js, the stacking package. Also at the top of this page is, thought there was a link to the actual package, but it looks like it's not on here, but I'll provide a link to the package itself. It's right here in GitHub. If you look at the README, there are quite a few functions here. I just linked to the commit to stacking function because we're going to go over this in a second. But this is the README for all of the different functions available to you in Stacks.js for not only initiating stacking transactions, but also reading stacking information. But basically the process is going to look the same for mostly the same for all of these different functions. Is you'll call the stack function, and I'm about to go over a demo of this from start to finish, so you can kind of see what the whole process looks like. But you're just going to call this JavaScript function, passing in all of the same parameters that we went over in the actual smart contract itself. And then you'll get the transaction ID as a response. And then so you can go and look at the status of that. But this guide that I'm looking at right now does not have the new fields in it that are required for stacking under POX4, like the signer signature. There's another page on the Hero docs that I have right here, specifically about Nakamoto updates for Stacks.js. Put that in the chat too. And so what you're going to want to do is if you go look at the README file for the Stacks.js package, you'll see all of the different functions that you can use and all of the different parameters that you'll need to pass into them, with the exception that there are new arguments that have been added to these actual stacking functions right here. So stack is equivalent to the stacks function we looked on the smart contract. Stack extend, stack increase, and then the aggregation commit indexed is the one that you'll actually want to use here. Stack aggregation commit is a legacy interface for this function. The POX4 or since Stacks 2.1, there's this stack aggregation commit indexed function. So when you're running that stack aggregation commit function, if you're doing that via JavaScript, this is the function that you'll want to use here. And then there's also this new method that's been added, sign POX signature, and this is how you can actually generate that signer signature that you need to pass in. So these new fields that you need to pass in look like this right here. So for example, if you wanted to run the stack aggregation commit function, you could go to the README here and look at this commit to stacking. This is the stack aggregation commit indexed function. You'll pass in the fields just like they have here, reward cycle, the pool Bitcoin address, and then this is your private key. But you'll also add in these new fields right here, the signer key, the signer signature, the max amount, and the auth ID. And remember that these need to be the same as what you passed in to actually generate the stacking signature here. So since this is all a little bit scattered, I wanted to create an example to kind of put this all in one place. And so I have a replit right here that we'll go over. And I made this public, so I'll drop this link in the chat. And I'm going to go over this in more of like a line by line fashion so you can actually see what's happening and hopefully get it integrated into your own. So I have a couple different packages that I've installed here, all from Stacks.js. I have Stacks Transactions, Stack Stacking, and then Stacks Network. And I'm going to go down here. The first thing I'm doing is I'm just hard coding in my Stacks address that I'm using. This comment's actually not relevant here. Get rid of that. And then what I'm doing right here is I'm just initiating a new client to actually interact with the Stacks blockchain itself. And I'm passing in the Stacks address that I want to use when I'm initiating transactions and broadcasting them up to the network. And then I'm specifying the network that I want to actually use. And I get that from right here. So if I wanted to do these on mainnet, I would just change this to Stacks mainnet. And then the devnet that Hank and I were talking about a minute ago in Clarinet, if you were using that, then you could pass that right here to a Stacks devnet. And that would then let you write these JavaScript functions, but they would be interacting with your local devnet. And all you have to do is change out the network and then change out any relevant, private keys and addresses and everything. And then you can broadcast it up to the correct network. But for this one, we're just using the testnet. So that initiates the actual client. And this is going to serve as my starting point for all of these transactions that I'm going to be initiating. So I just have an async function here that's going to do two things. It's going to generate our signer signature, and then it's going to initiate a stacking transaction using that stack stacks function. So what I'm doing here is first I'm getting some of the POX info. So this function right here is very similar to the POX endpoint that the Hero API provides, but this is going to give you some information about the current status of stacking and the POX contract. So the main place that I'm using this is to get the reward cycle ID so that I can pass this in right here. So right here, I'm generating my signature. So I'm using that new sign POC signature field, passing in the topic, which is stack stacks. This corresponds to an enum field in stacks.js, the new POX4 signature topic enum. And this corresponds to all of the different functions that you can generate signatures for. So it's the stack stacks and the stack aggregation commit, depending on what you're generating that signature for. So passing that in here. And then I want to be stacking for the next reward cycle. And so I'm passing in the reward cycle ID right here. POX address, this is the Bitcoin address that I want to actually send the rewards to. I want to stack for 2 cycles. And then what I'm doing right here is Replit just has a secrets function built in. And so I am using an environment variable here for my private key. But importantly, for this particular part of the function, I need to wrap this in this create stacks private key function, which comes from the stacks transaction package. So this will convert what is just a string into the correct format for generating the signer signature here, creating a random auth ID, and then this is my max amount in microstacks. And so what I did here was I just looked at the current minimum threshold from this getPox info function here, and I just set that to my max amount. And so this is going to actually generate my signature. I'm going to comment this out real quick so that I can run this. And this one too. Zoom interface is getting in the way and I can't run it. 1 second. Run this and I've got my signature right here generated. So then now that the signature has been generated, I can jump to actually initiating this stacking transaction. And again, I'm going to be passing in a lot of the same parameters here. So this calling this function will return the transaction ID. So I'm just going to set the constant here, passing in the same amount that I want to actually stack, passing in that same Bitcoin address, the same number of cycles, and then the burn block height. So when I'm calling the stacking transaction, I need to pass in the burn block height that corresponds to the reward cycle that I want to actually stack in. And so since I'm doing the current reward cycle, I'm going to pass in the current burn chain block height here. And again, that's getting pulled from this same getPox info function. And here are the new arguments that are part of Nakamoto. So my signer key, this is just the public key of the signer that I used to generate this signature right here. The signer signature is I'm just passing in what was generated by this function into that. Same max amount, same auth ID, and then again, passing in my private key so that I can actually broadcast this function. I'm not going to call this here because we don't want to sit here and wait for a testnet transaction, but I did call it last night and it was successfully confirmed in the anchor block. So this transaction right here that's been confirmed, this transaction was broadcasted using this exact code right here. And so hopefully you can use this as sort of a template for conducting your own stacking functions. If you wanted to do these, the delegate stacks functions and the stack aggregation commit, it's going to be the exact same process. You'll just need to adjust the parameters based on exactly what your setup looks like and what your use case looks like. So that's that's the walkthrough of the Stacks.js package and how to actually stack. I'm also working on adding a written version of this to the docs. So that way, similar to how I did the stacking contract walkthrough, there will be a tutorial for how to stack with Stacks.js that will just run through each of the different scenarios. So it'll run through the stack stacks function, and it'll run through also some of the JS functions you want to use as a pool operator. But you should be able to take this code and use it as a template and just adjust the specific parameters and function calls depending on on your setup. So that is the Stacks.js walkthrough for stacking. And I will stop sharing my screen and we can jump into any additional questions that anybody has.
Question here.
Hey, yep.
Can you see?
Cool. Yeah. I'll hang out for a couple more minutes if there's any questions, but otherwise, otherwise we can call it here.
I think we had a question, but Bart, if you were asking one, your audio cut out.
Okay, okay. Can you hear me now?
Yes, yep, I can hear you.
So you've demonstrated the solo stacking flow in the using the Node Stacks.js, right?
Mhm.
But the process for the pool operators is much more complicated, right? Because of the commit, right? Can you go just for a few minutes through these stacks commit transactions and also the increase transactions, the extend transactions? Like we are forced to basically push these transactions into the future, right? If you have a delegation for, like, let's say 5 cycles, then you need to prepare the transactions for each cycle, right?
Mhm.
So what's the best approach here when you're running a signer? You have the signature, which can only be used once. That's what I understood. So you need to generate 5 signatures and 5 commit transactions, right?
Yeah, so for each of those transactions, you'll need to generate a signature and then generate, a separate aggregation commit transaction. And I'm currently working on a written guide for doing that. It's not quite done yet, but I'm hoping to get that published early next week to go through that. For this live demo, I only prepped the stack stacks function, but I will share my screen real quick and show you in the README for the actual Stacks.js package. So this would be all of the functions are laid out right here in their README for stacking the delegated stacks. So this would correspond to the delegate stack stacks function. And it's going to be a really similar process to what we just did. It'll just be a couple more steps because instead of just doing the stack stacks function, you're doing the delegate and then the commit function. But these are all laid out right here for exactly the parameters you'd need to pass. And then the extend is here as well, increase, and then the commit function here. This is where you'll need to do it the way that it's laid out here, but also add in those additional fields with the signer signature and everything. So depending on your setup and how you want to actually perform these transactions, you can set it up to generate the signature really however you want. If that's something that you want to build into a UI for people to use as like an admin, you can do that, or you can set up the JavaScript to just run and create it like that. But all the functions are laid out here. I'm working on right now more of like a step-by-step, do this and then do this. But until that's done, hopefully early next week, all the function references that you'll need to do that are here in the README for the stacking package.
Okay. Okay. One more question, if I may.
Yeah.
So there is this I think it was in box 2. I found this somewhere in the code. There are 2 functions, stack aggregation commit and stack aggregation commit indexed.
Mhm.
the difference? Why is the second one there?
Yeah, so if you look at stack aggregation commit, you'll see that the value it returns is slightly different. The stack aggregation commit will just return an OK true, but the stack aggregation commit indexed will actually return the reward cycle slot number that the aggregation commit function has been assigned. And so the stack aggregation commit is just a legacy interface for people that had written their contracts before it was upgraded so that they can still call that function and not have to redeploy their contracts. But the stack aggregation commit indexed function is the new version of that just has the different return format there. So it's really just a legacy interface versus the current interface, but they both work. And then Hank, correct me if any of that was incorrect.
Yep, totally true. They both work. The indexed, the different return type, it's really mainly helpful for smart contracts that are calling into that function, that they want to, do some logic based on the result. And so if all you have is like true or false, you're just more limited there. But if you're not calling it from a smart contract, it really doesn't matter. Yeah.
Okay, thank you. I ask this because the docs reference the non-indexed function everywhere, basically. I think it's a good idea to change that, but yeah, that's it. Thank you.
I think so too. I'll work on getting that updated.
Mm-hmm.
Okay, another question from Marcus. Is there anything we would need to do to prepare additionally on the infrastructure side for next week's upcoming changes? If you're referring to, are you referring to the testnet activation to where the fast blocks will be activated, or are you referring to the mainnet POX4 being instantiated? Or maybe both. Yeah, cool. So on the testnet side of things, as long as your signer is running and you've gone through the stacking transactions that we've been covering the last couple weeks, you should be good on the testnet side. I don't think you'll need any infrastructure changes for the fast blocks and Bitcoin finality activation as long as your signer is already running successfully. But for the mainnet side of things, for POX4 being instantiated on mainnet, basically you'll want to make sure that you've gone through the same process that we've been testing out here on testnet, where you're getting your signer up and running and then executing a successful stacking transaction. You want to make sure that you do that, but for mainnet. So your node will be connected to mainnet, your signer will be running on mainnet, and you'll be executing these stacking transactions on mainnet. But the process itself should be pretty much the same, except for making sure you change the config fields and everything so that you're interacting with mainnet instead of testnet.
And just on that note, we just cut a new release candidate, RC2, with an heads up that if you look at the GitHub releases page and the binaries there, that was actually built off of the wrong commit. And so it's probably fixed by now if it isn't already. There's also a branch, I can share. But you'll want to use that when you're setting up your mainnet infrastructure.
And then one more question. What's the best practice for monitoring that node and signer are performing properly after joining the active set in a reward cycle? Hank, jump in if you have any better practices in this, but from my understanding, the best practice is just to periodically check your logs and make sure that your signer's still operational. Yeah, I don't know if there's anything different than that, Hank, you'd advise people to do.
Yeah, and I would admit that there's, that's not a great answer. And so basically providing better kind of like observability on the signer specifically is something that we really want to improve. Even just in the logging side of things, just more information is more helpful. Potentially something like a status endpoint that just provides kind of high level information, nothing private, and then Prometheus as well, for sure. So yeah, we have that for the Stacks node, not yet for the signer, but definitely something we want. And I would say, if you know, any kind of requests or recommendations on that front, you know, even as you've gone through this process once, you know, I'm all ears.
Yeah, I've gone through that myself, and the signer itself provides very little information on what's going on, actually, I think. There's like a couple of lines of logs when it starts, but then you don't really see anything. So that might be of a bit of a concern, but I think it's fine. Like there's other ways to determine the health, more complicated ways, of course, but still.
Yeah, and one of the things that I know many of you saw was that it still says that line, you know, not registered for cycle N, even if, you know, the upcoming cycle, even if you've already stacked. This, you know, relates to kind of like the next cycle's signer set or reward set isn't actually determined until towards the end of, you know, the previous cycle. However, I think there's a lot we could do, probably not in the signer itself, but in terms of tooling, to sort of, you know, look at the on-chain data, all of the pending transactions, to be able to, you know, provide more information of, yeah, like, you know, whether you're fully stacked and other metadata like that. Um, a lot of warnings. Yes, the failed to get aggregate public key. I mean, you probably only had about like 1 billion of those logs, so I mean it's not that big a deal. But yes, yes, it is fixed in the new release candidate.
So one more thing. I've been running my testnet node on the next tag. I'm running it on in Docker. Should I be switching to pinning to a specific version, like the one you mentioned, the RC2 or RC1 or whatever? Or should I continue using the next tag?
Um,
Because I thought
we
that that one's the most up to date, right? But it's
yes.
the development tag, I think.
Yeah, you know, we've always in the past used Next for kind of like, you know, major consensus breaking changes. And so, you know, for the past couple of months, that's been like everything. We just moved to the develop branch for, you know, Nakamoto and Epoch 2.5 related changes. And so the new release candidate is actually based off develop. So if you wanted to use a branch and kind of build from source, I would recommend develop. But otherwise, you know, the release candidates and then certainly the release versions will just be, you know, a stable, tested in production release.
Yeah, and for the mainnet next week.
As you are preparing, use the most recent release candidate for sure. And then I'm not sure exactly when, you know, we'll move from release candidate to just proper release. But for right now, definitely use the latest release candidate.
Okay. I think that this should be more clear to all the mainnet operators. I didn't found that information. Okay, okay. Got it. Thank you.
Actually, yeah, just sorry to go back to that point. So mainnet should be running release candidate. Like, how long will the normal release be supported?
Normal release, like once we move from, you know, .rc to just regular version.
Yeah, I think like right now we're running v24, right, on mainnet.
Right. Yeah. Once we have a proper release, it's generally pretty infrequent that we release kind of like a minor version improvement. I think there is actually like 24.0.1, which you don't have to be running. And so it's kind of hard to say. it's generally when there's like, obviously not consensus breaking changes, but, things that, I don't know, provide convenience or maybe like Prometheus metrics. I would say, for the signer, because, that binary is not necessarily consensus dependent. It's more kind of like an actor on the network. I would expect more frequent releases, as compared to once every few months. But I'm not quite sure yet. And, certainly we will keep you all informed.
Cool, thanks.
Yeah.
Cool. Yeah, awesome. If there are no other questions, I think we can.
Sorry,
Oh yeah, go ahead.
I do have another one. This is regarding the SBTC.
Okay.
So, I've seen a lot of those mint transactions, right? And I'm just wondering on what's the timeline on activating this? Is it like still May, late May, or not on the mainnet specifically?
I don't know the exact time. I know the estimate has been about 2 months after Nakamoto comes out on mainnet. And so that would put us at sometime in June, but that's a loose estimate, because basically what happened is we built and released a developer preview version of SBTC at the end of last year. And that sort of led to a lot of realizations about optimizations that could be made in the design mechanism, specifically the opcodes that are used to process the transactions on the Bitcoin side of things. And so there were some changes that are being made to the design mechanisms of how SBTC works. And so depending on how quickly those are implemented, if they've all been basically decided upon for sure, that timeline can change. But the last I heard, the estimate
Yeah.
was 2 months after Nakamoto's released.
Yeah, I can just chime in here really fast. I don't think it'll be in June. Our current estimates will be that it will be in Q3. And so we'll definitely communicate with you guys sooner. We're currently planning on doing a bootstrapped SBTC phase. So that'll likely remove some of the complexity with the V1 launch, possibly with a more like whitelisted signer set. That would be chosen by some sort of governance vote. But right now we're planning on releasing some more details within the next 2 or 3 weeks or so. So but yeah, as of right now, you won't need to worry about that until later in Q3.
Okay, got it. Thank you.
Sure thing.
All right. Thanks, everybody. I'll continue to work on adding some of this stuff to the documentation, getting some more step-by-step guides written, and then the suggestions that we got here were also super helpful, both for changes that can be made in the code and then also some improvements that can be made in the documentation. So we'll start getting those worked on too. And in the meantime, just continue to reach out to us if you run into any issues or have any questions or suggestions. But other than that, we'll call it good here. Thank you, everybody.
Thank you.
Thanks, everyone.
Thank you. Bye.